Hey everyone, I'm Said and welcome back. In this video, we're gonna learn the telescoping rule in sigma notation. A telescoping sum is a sum in which many terms cancel each other after expansion. Usually the expression has the form the sum of ai minus ai plus 1 from I equals 1 to n. If we expand it, we get if I equals 1, so we have a1 minus ai plus 1 means a2 plus when I equals 2 we have a2 minus a3 a2 minus a3 plus when I equals 3 we have a3 minus a4 a3 minus a4 plus and finally when I equals n we have an minus an plus 1 an minus an plus 1. Now notice that the most of the middle terms cancel out, means a1 minus a2 plus a2 minus a3 plus a2 minus a3 plus a3 minus a4 a3 minus a4 plus an minus an plus 1. So negative a2 plus a2 is nothing, negative a3 plus a3, and finally negative an plus an cancel out and we are left with a1 minus an plus 1, right? So we have the sum of ai minus ai plus 1 from I equals 1 to n equals a1 when I equals 1 a1 minus when I equals n we have an plus 1. This is called the telescoping sum because the sum collapses just like a telescope. For example, the sum of I minus I plus 1 from I equals 1 to 5. Let's expand the summation. The index I goes from 1 to 5. So we have when I equals 1, we have 1 minus 2. 1 minus 2 plus when I equals 2, we have 2 minus 3 plus when I equals 3, we have 3 minus 4 plus when I equals 4, we have 4 minus 5 plus when I equals 5, we have 5 minus 6. Now simplify each term. We have 1 minus 2 plus 2 minus 3 plus 3 minus 4 plus 4 minus 5 plus 5 minus 6. So most middle terms cancel. So we have equals 1 minus 6 is negative 5, or the sum of I minus I plus 1 equals I is 1. So we have 1 minus I is 5 means 5 plus 1 equals negative 5. Number 2, evaluate the sum of 1 over I minus 1 over I plus 1 from I equals 1 to 6. This is a classic telescoping sum. So let's expand it term by term. We have when I equals 1, we have 1 minus 1 half, 1 minus 1 half plus when I equals 2, we have 1 over 2 minus 1 over 3 plus 1 over 3 plus minus 1 over 4 plus When I equals 6, we have 1 over 6 minus 1 over 7, right? So 1 minus 1 half plus 1 half plus negative 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 plus 1 over 6 minus 1 over 7. Now look at the cancellation. So the answer is 1 minus 1 over 7, or I equals 1, 1 minus I equals 6. 1 over 6 plus 1, 7 is 6 over 7. Number 3, evaluate the sum of 1 over k minus 1 over k plus 1 from k equals 2 to 7. This summation is very similar to the previous one, but this time the index starts k equals 2. Let's expand it carefully. When k equals 2, we have 1 over 2 minus 1 over 3. 1 over 2 minus 1 over 3 plus, when k equals 3, we have 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5 plus, when k equals 7, we have 1 over 7 minus 1 over 8, right? So we have 1 half minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 7 minus 1 over 8. Now cancel the middle terms. We have 1 half minus 1 over 8. So the first term we plug in k equals 2, so we have 1 over 2 minus the second term we plug in 7 minus 1 over 7 plus 1 is 8. So we have 3 over 8. Number 4. Evaluate the sum of 1 over I times I plus 1 from I equals 1 to n. This example does not look telescoping at first, but we can make it telescoping by using partial functions. We want to rewrite this fraction as a difference of two simpler fractions, right? As you know, 1 over I times I plus 1 equals 1 over I minus 1 over I plus 1. Let's check. 1 over I minus 1 over I plus 1 equals, if we take the common denominator, we have I times I plus 1, and the numerator we have I plus 1 minus I. So we have 1 over I times I plus 1, right? So the sum of 1 over I times I plus 1 from I equals 1 to n equals the sum of 1 over I minus 1 over I plus 1 from I equals 1 to n. Now expand. When I equals 1, we have 1 minus 1 half. 1 half plus, when I equals 2, we have 1 half plus 1 over 3. And when I equals n, we have 1 over n minus 1 over n plus 1. So all middle terms cancel. So we get 1 minus 1 over n plus 1. So in this case, when I equals 1, we plug in the first term by I equals 1. So we have 1 minus, and the first term we plug in n. 1 over n plus 1, or n over n plus 1. Number 5, evaluate the sum of ln of I plus 1 over I from I equals 1 to n. This is a more advanced telescoping sum involving logarithms. We use the logarithm property. We know that ln of a over b equals ln of a minus ln of b. So ln of I plus 1 over I equals ln of I plus 1 minus ln of I. So the sum of ln of I plus 1 over I from I equals 1 to n equals the sum of ln of I plus 1 minus ln of I, right? Now expand, we have from I equals 1 to n. When I equals 1, we have ln of 2 minus ln of 1 plus when I equals 2, we have ln of 3 minus ln of 2. And when I equals n, we have ln of n plus 1 minus ln of n, right? So ln of 2 minus ln of 2, ln of 3 and negative ln of 3, and finally we have ln of n plus 1 minus ln of 1, and as you know ln of 1 equals 0, so the answer is ln of n plus 1. So the sum of ln of I plus 1 over I equals ln of n plus 1.